and hi, my name is Muhammad Faiz Amar, and I will go to the introduction for this group project. First, we have the objective. So the objective is to analyze the outcomes of rolling a six-sided die through the calculation of experimental and theoretical probability focused on even and odd number. The second one is to compare experimental and theoretical probability for rolling a die, everything different and their implication in terms of accuracy and random variation. And third one is to conduct a hand-on probability experiment with suite of varying recording and analyze the frequency of outcomes. Now we move to the problem statement. Everyone know to understand probability is an important part of mathematics, but many students struggle with connecting the theoretical concept to the real-world application. Theoretical probability is based on what we expect to happen under perfect conditions, while experiment probability comes from actually performing experiment and collecting data. Often, these two don't match exactly because of randomness, limited sample size, or error during the trial. This project focuses on helping students explore this gap through hands-on experiments. By rolling a die multiple times and recording the result, so they can see how often even and odd number appear and compare the experimental probability with the theoretical expression. Similarly, a sweet picking experiment allows students to work with different flavor and frequency, collecting data to calculate probability and analyze patterns. Through this activity, students can better understand why probability is sometimes different in practice, the importance of conducting multiple trials for accuracy, and how to interpret results. This approach aims to make the concept of probability more practical and engaging while improving their skill in data analysis and critical thinking. So that's all for me.
Assalamualaikum and hi, my name is Muhammad Aziz Ashraf bin Mazin, and today I will explain about methodology of roll a dice. First thing first, you need to pick your die using your only index finger, your thumb, or using your palm of your hand. Next, you need to shake it to randomize the outcome. Make sure to not look to any sides to avoid any bias. After that, you need to release a die with a flick on your wrist to add some force. Nextly, roll on a flat surface. Make sure die land on a flat level surface where it can bounce a bit. A pedal surface like fell or flow work well to absorb energy and ensure it to settle quickly. Wait it for stop. Let the die come to a complete stop on its own without touching or interfering. That's all. Thank you.
Assalamualaikum. My name is Muhammad Danish bin Muhammad Kamri, and I'm going to continue about finding and calculation. For question A, write the exact sequence of odd and even number occurring in table 1 under outcomes. For outcome 1, 5 frequency, outcome 2, 3 frequency, outcome 3, 3 frequency, outcome 4, 3 frequency, outcome 5, 6 frequency, and outcome 6, 10 frequency. For question B, find the experimental probability of rolling an even number. The formula is P even equal to number of even number rolled over number of experiment trials equal to 3 plus 3 plus 10 over 30 equal to 16 over 30. And for question C, find the theoretical probability of rolling an even number. The formula is P even equal to number of favorable outcomes over number of possible outcomes equal to 3 over 6 equal to 1 over 2. And for question D, find the experimental probability of rolling an odd number. The question is the formula is P odd equal to number of odd number rolled and number of experiment trials equal to 5 plus 3 plus 6 over 30 equal to 14 over 30. For question E, find the theoretical probability of rolling an odd number. The formula is P odd equal to number of favorable outcomes over number of possible outcomes equal to 3 over 6 equal to 1 over 2. And for question F, what is the difference between experimental probability of rolling an even number and the theoretical probability of rolling an even number? Write answer as a percent rounded to the nearest whole percentage equal to experimental probability of rolling an even number minus theoretical probability of rolling an even number equal to 16 over 30 minus 1 over 2 multiplied with 100 equal to 3.3% equal to 3%. Last but not least, for question G, what is the difference between experimental probability of rolling an odd number and the theoretical probability of rolling an odd number? Write answer as a percent rounded to the nearest whole percentage equal to experimental probability of rolling an odd number minus theoretical probability of rolling an odd number equal to 14 over 30 minus 1 over 2 multiplied with 100 equal to negative 3.3% equal to negative 3%. That's all from me. Thank you.
For the experiment 2, question A. Integrate upper value 3, lower value 0 as in bracket 2m plus 1 over 2 dm equal to 1 as in bracket m square over 2 plus m over 2 in bracket upper value 3, lower value 0 minus 1 as in bracket 3 square over 2 plus 3 over 2 equal to 0 as in bracket 9 over 2 plus 3 over 2 minus 0 equal to 1 as in bracket 12 over 2 equal to 1 as 6 equal to 1, and the answer of S is 1 over 6. For the question B, find the P in bracket 2 less than m less than 5. So m in bracket 2 less than m less than 5 equal to integrate upper value 3, lower value 2, 1 over 6 in bracket 2m plus 1 over 2 dm equal to 1 over 12 integrate upper value 3, lower value 2, 2m plus 1 dm 1 over 12 in bracket m square plus m upper value 2, lower value 2 1 over 12 in bracket 3 square plus 3 minus 2 square plus 2 in bracket equal to 1 over 12 in bracket 12 minus 6, and the final answer is 1 over 2. Thank you.
Question C, step 1, relationship between A and M. The random variable A is obtained by adding 2 to the continuous variable M, so the expectation E in bracket M can be written using the linearity property of expectation. Step 2, find E in bracket M. To compute E in bracket M, we use the definition of expectation for a continuous random variable. For the step 3, solve for S. The value of S is determined from the normalization coordination of a probability density function. Last step 4, compute E in bracket A. Once E in bracket M is determined, substitute into a E in bracket A equal to E in bracket M plus 2.
Now is the part of solution. Based on the experiment, we can conclude that the probability of rolling an even number or odd number on a die varies with each trial. In this study, we record the result of 30 rolls. The experimental probability of rolling an even number 2, 4 or 6 was 16 out of 30. In theory, the probability of rolling an even number is 3 over 6. Similarly, the experimental probability of rolling an odd number 1, 3 or 5 was 14 out of 30. The theoretical probability of rolling an odd number is also 3 out of 6.